For the last few months, I've been designing this robot Stewy. To see if there's interest, I'm currently selling them on Kickstarter. In this video, I'll be building Stewy, then giving it away to one of you. So stick around to the end, and I'll explain how you can win this one. Alright, let's get to the build. I'll start off with the parts that need to be glued in place. Each arm has a magnet glued into the end of it for the ball joint. The arms also need one of these plastic servo horns glued in so that it can connect to the motor. I used way too much glue while trying to film this one. I'd recommend adding just enough to cover the outside of the horn. We'll put together 5 more of these, set them somewhere to dry, and in the meantime, start on the next arm link. This next link will be a carbon tube with a ball joint on one end and a hinge on the other. On the ball joint end, I marked how far the threaded rod went into the steel ball, unscrewed the ball, then glued the rod back into the carbon tube just past the marking. All this was a bit overkill though. I could have just glued in the assembled rod and bearing. The other end of this link needs a hinge joint. Let's go ahead and make that by snapping a threaded tang into this small clevis. These things are a bit difficult to pry open, but they hold together well once they've been assembled. To finish this link, we just have to glue the hinge joint we just made into the end of the carbon tube. Again, we'll make 5 more of these, set them somewhere to dry, and start on the next part while we wait. Starting on the base, the first thing to be put in place is the circuit board. It'll be attached with some standoffs. 3 of them will be screwed on with the 5mm bolts. Once the standoffs are on, we'll line everything up with the holes in the base and flip it over. Now the PCB can be secured with a few more bolts. After that, all the servos are ready to be installed. They go in from the inside of the base. It's a tight fit getting some of them in, but you can do it without forcing anything. Each servo is then locked in place with 2 5mm bolts. Before closing up the base, the servos are plugged in, following the labels on the PCB. With everything plugged in, we'll add these square nuts into the pockets on the sides of the base. These square nuts allow us to bolt down the bottom of the base from the outside, locking everything in place. Also on the bottom of the base, we'll attach these rubber feet, lining them up with the indentations. They'll give Stewy more traction, and their spherical shape makes setting up collision modeling in simulation easier. Before we attach the arms, it's important to make sure we have the servos rotated to the right positions. To do that, we'll install the microcontroller. Make sure to program it first. I'll have a written tutorial going over the steps to do that, along with the code in the description of this video. With the microcontroller programmed and installed, we just have to power on the robot, and it'll automatically center all the servos. Now that the arms are ready to install, it's important to get them as close to their 0-degree position as possible. This position is when the center of the ball bearing at the end of the arm is horizontal with the servo's rotation point. You're not going to be able to get them perfect, but that's expected. We can fix that by adding offsets in the code later. The last thing we have to put together is the top plate. If they're not already attached, we'll screw in the bearings on the ends of each carbon rod. We can then attach each arm to the top plate. They're attached by pinching the top plate between 2 ball bearings, and everything is locked in place with a lock nut. I've trimmed off the ends of the threaded tangs on my robot, but you can leave them extruded past the lock nuts if you'd like. The last step is to attach the top plate to the base, but before we get there, I'd like to thank PCBWay for supporting this video. They 3D printed the arms, base, and top plate you see in this build, all which turned out exceptionally well. They also sent me the custom circuit board, as well as the microcontroller I used. Ordering 3D printed parts from their site is super simple. You just drop in your design file, then choose the material and quantity you'd like. Okay, now for the most satisfying part of the build, attaching the top plate. The bearings are all attached to the magnets on the end of the servo arms. These magnets provide a strong connection that holds the top plate on well, but it's also weak enough that these joints will come apart before anything else breaks. To make it move, we just have to power it on, connect to the Stewy AP Wi-Fi, then in a browser go to robot.local. Here you can cycle through the different pages, testing to make sure everything works. As promised at the beginning of the video, I'll be giving away this copy of Stewie that I put together here. To win it, leave a comment below saying what you would do with it, whether that's building some sort of add-on, attaching certain sensors or tools, or teaching it to do some task. Once you've left that comment, go to the Kickstarter page, save the project, and copy your comment as a direct message to me. I'll pick my favorite and announce it on this YouTube channel in 2 weeks from this video's release. There's no need to give money to the campaign to enter, and I will not be taking that into account. But I am very thankful if you decide to. Backing the Kickstarter will allow me to continue this project in the future, build a community around it, and continue providing resources here. At the moment, Kickstarter is the best way to support this project, so it would mean a lot if you would check out the campaign. Thanks for watching. I hope you enjoyed the video.